Excellent. All right, Whitney. So thank you all for joining. We really appreciate you taking time out of your busy day to come join us here at the Triton Community Meetup. We don't have any talks today, but what we would like to do is to go over, like, some folks have been to the Triton Developers Conference, which happened just last week, and we'd like to hear from you about, like, what you found interesting, or if you watched the videos, what you thought was good, what was bad, and what you'd like to see more of, like, in the following year. So I don't know, is Ofer here? Nope, Ofer's not here. So folks who did attend, or folks who did see the videos, let me know what you thought. And I'm opening up the floor, and I could toss people under the bus here and just say, like, I could point people out. But if you would like to unmute yourself and, like, just give us a brief rundown of, like, some of the things you saw, what you thought was interesting, we'd like to hear about it. Luca, would you like to say something? Unless that was like a cough.
Yes, sorry, accidentally unmuted. But I missed the first part of the question, so that's why I didn't want to chime in.
Oh, no worries, no worries. So did you go to the conference, or did you see the conference videos from the Triton Conference?
Yeah, I was there. That was like the one before PyTorch Conf, right?
Yeah. So what did you think about it? What did you like? What did you thought? What did you think was interesting?
No, it was great. I think it was really I think it really showed like the breadth of kind of like interest in Triton and how everybody's like really trying to make it better with extensions or working on it directly, and how much people care about its performance and so on. A lot about warp specialization. That was definitely the single takeaway.
Okay, a lot on warp specialization. Did you find out from after looking at the presentations, are there things that you could take away? Did you find out you could take away things? Were you able to implement anything based upon, like, what you saw?
I mean, I learned a ton, but not. Yeah, I don't know if there was like something that was like, oh, directly it can help me write Triton kernels. Okay. It was more like, oh, this is really cool stuff and really helpful to understand, and I'm sure it'll come handy in the future.
Great. And by the way, what kind of kernels do you write? Or what kind of kernels are you interested in?
I actually have to admit I haven't written a single Triton kernel, but I work on the like VLM torch compile integration, which so torch compile generates Triton, and so we care a lot about it from that angle. I'm also just in general like personally interested in all these abstractions that are coming out and DSLs, and yeah, it was very cool.
Okay, abstractions and DSLs. Okay, excellent. DSLs. Okay, looking around the room, anybody else like to go? Anybody else have like some things that they would like to say about, like, what you thought was interesting? If not, I will point out some folks who I do know who are at the conference and who might be able to say something interesting. Booyah, go ahead.
Yeah, I have a comment. Thanks, Bill.
Yeah, no worries.
A lot of great content. A lot of great work people are doing on different aspects of Triton. It was really neat to see. Just from a presentation perspective, I'm just going to point out that would have been nice to really take advantage of that huge screen. And since we're looking at a lot of good, examples, it was kind of frustrating to have those little screens way over on the sides. So that's my only, gripe about the conference. Other than that, everything was great. It's great to meet up with everybody and see everybody there, and just to get to reconnect. So
I'll jump on top of Simon, since we're at the same company, I guess. I really liked the step-by-step stuff from NVIDIA. We did these things. That I think was, for me, the right level of detail, almost from a user perspective of like, here are the steps that we go through to do optimization and how you might do this yourself on something else. So I really liked that level. Like, there were lots of good presentations, but that one for me really stuck. Like, in could take away, this is exactly how you use Triton. And then, I asked the question, and I'll keep asking the question, like, anything around new novel AI hardware, I think would be interesting. There are definitely some questions from the audience, but not so much on the presentation side of folks talking about Triton or optimization in the context of, it was very GPU centric. Hopefully next year there's more devices ready and we can have more stuff that's covering more devices. Yeah.
Okay. That's a very good point. I think also at the follow-up, not the follow-up, but the main conference, which was the PyTorch conference afterwards, it seemed like there were a lot of folks also that were like into embedded devices, and there were a lot more demos, at least at the PyTorch conference. Maybe at some point in time, like in the future, as part of the Triton conference, we can have more people do demos or things like that to actually show off. Because we did have the poster sessions, but maybe demos might be kind of nice too. Okay. Other folks who went, or other folks who saw the videos. Maybe Corbin or Puyan.
Yeah, you I think you called on me earlier. So I went to the PyTorch conference as well as LLVM and the Triton conference as well as LLVM and PyTorch. And a big theme I saw across a lot of these DSLs is the need to extend them for more hardware, more features. Someone needs to mute their. Okay, sorry. I'll try to speak even though there's some. Okay, that's better. Yeah. So I got a sense that there's a need for maybe a more unified sort of a extension system for Triton generally. I don't know what the right solution is, but there are a lot of different ideas out there. A really interesting one I saw at a different conference was that there are certain languages in DSLs where their MLIR dialect doesn't take fixed size tensors. They're instantiated at when you launch the kernel. And so you can then embed the MLIR into like almost like an inline assembly, but a tiled inline assembly for Python kernels, which I thought was interesting. But yeah, it gave me a lot of food for thought as far as ways we can maybe provide a interface for extending Triton.
Excellent. Always looking for ways to like make Triton better. That's a good one there, Puyan. Other folks? Any comments on like what Puyan's observations were? Does it sound reasonable? Do you think that we should be going that route? Other alternatives that people know about? If not, I will call on somebody else to see whether I can get another volunteer over here. I don't know, looking down the list, right underneath Puyan, I see Sarah. Sarah, yeah, I haven't talked to you yet. Just kind of curious, like, were you able to attend, or did you have you seen the conference?
Hi, yeah, I was at the conference, so I was able to attend and presented a couple of posters with some of our colleagues. I generally really enjoyed the conference this year. I thought it offered a nice range of talks and how people were using Triton and extending Triton. One of the pieces that we're starting to look into was Helion, which was, I think, commented on a little bit at the Triton Developer Conference. So we're just starting to look in the Helion tutorials and see how that fits in with Triton and PyTorch.
Okay. And kind of curious, what kind of kernels are you interested in, or what kind of models do you end up building, or like what way would you actually want to see like maybe more the Helion direction in terms of what should they be looking at if you look at the Helion team?
Yeah, I mean, I think we're just getting a sense of that. Our team works on some of the Triton kernels for BLLM, and we are interested in a variety of hardware too. So that makes Triton a good option.
Oh, okay. Does your hardware include processors that are not GPUs?
So we've mainly focused on like the NVIDIA and AMD GPUs, but I know other GPU support outside of the Triton branch for like Intel GPUs and other processors are sort of being developed and available.
Okay, that sounds great. No, I'm if we can connect other people together, that's a great thing. Okay, going back to the top of the list. how about, I don't know. I think we've heard some. How about Alexander? Alexander Zinoviev. Alexander? Poking once. How about Ari? Yeah, I call people out. If you want to unmute, you're more than welcome. Just simply say, yeah, you'd like to pass. All right. How about you, Corbin? Anything you'd like to comment
on? Yeah, I mean, I guess so. Puyan and I are have been working on some of these extensions, and we're at the point where we're starting to get folks onboarded into or starting to get folks to, I guess, propose and onboard projects that they want in these extensions. One of them is an implementation of distributed Triton. Another one is Triton for different architectures. If you have a project that currently lives outside of Triton, but you think would benefit from, I would say, being, I guess, integrated in kind of an extension type way, and is mature enough that you think can fit into that model, reach out and let us know, and we'll take a look.
Okay. Corbin, do you have like a web page or anything that they can look at to figure out would this be a good candidate or?
Yeah, we're in the process of open sourcing some stuff.
Okay.
I think there's a couple of PRs that need to get merged upstream that should be in this week, and then we're going to start a kind of like an extension repository in the Triton Lang repo, and kind of go one by one as we have projects that want to be onboarded to it. Once that starts kind of stabilizes, we can point folks to it.
Okay.
Yeah, we're mainly just waiting to have things reviewed and get some feedback. But the short version of it is that we have loadable passes and loadable dialects that are separately compiled from Triton that can hook into the Triton compilation system.
Puyan and Corbin, I think I'm gonna probably have to invite you back to actually give a talk on this too, because I think this is something that actually would benefit from having slides and having a good presentation.
Yeah, we're not at the point where we have slides yet. We're just writing our docs, our README for it. But yeah.
No worries.
Yeah.
No worries. So going down the list of other folks who might like to comment on the conference, things that you saw at the conference that you thought was interesting, but you'd like to call it to other folks. Going to the list, Daniel Nielsen.
Nielsen's right. I was not at the conference, so I have nothing to comment, and I haven't seen the videos yet.
Oh, you haven't seen the videos yet? The videos are up. They're pretty professional. I was very impressed with the work they did.
I've seen previous years. I just hadn't gotten to this year yet.
Okay. No worries, Daniel. Okay. Going down the list a little further. How about you, David? Anything that you saw that was interesting? David Grove.
Sorry, I didn't go. I'm just here to listen and find out what people observe.
No worries, David. No worries. Thanks very much for responding and unmuting. All right. How about you, Drew?
Hey guys, can you hear me?
Yes, we can hear you.
Okay, yeah. I mean, just thoughts. I was more focused on flex attention. So I think there were opportunities in two spaces, I would say. One was making the flex attention kernel context parallel. So that kind of reduces the memory requirement, and it does a lot of the distributed setup, which is kind of nice because of the whole Monarch announcement. That was one thing. And the other thing that I saw, which was pretty good, was the Python support for the different data types, MX, FP8, and there are two others. So maybe, Triton can kind of support those data types, adopt them, or emulate them. I think those could be interesting opportunities for future direction, maybe. Yeah.
All right. For going down the list, Jason.
You guys.
Yes,
so
we can hear you.
we're talking about conference
Yeah,
inputs.
conference.
I actually I didn't get to attend. I had some people on my team did. We had I'm from AMD. We had a couple AMD talks there that I hope y'all got a chance to take a look at. We were kind of sharing some of our latest improvements and advancements and things. So yeah, no, but I've heard it all went real well. I wish I could attend. Oh, maybe I'll be there next year. Yeah, thanks for. Yep.
Oh, I was just going to say I attended some of your people's talk at the Python the PyTorch conference.
We had people there too.
You did show a bunch of really nice fast. I think some faster attention kernels on AMD, and I even asked some of your folks too to see whether or not they would be interested in getting them integrated with Triton Bench, and I think they're really happy with that.
Yes, for sure. Yeah, Triton Bench is kind of becoming an interesting target for sure for the community. I think so. Yeah, we'll be focusing on that a little bit more going forward.
Going down a little further. Xiaohu. All right. I'll go to the next person. How about Harsha? Harsha, did you attend? Or did you see any of the
Sorry,
videos?
I didn't. Sorry, no, I didn't get to attend it.
No worries, no worries.
Comments.
Okay. How about you, Hong Tao? What did you learn, or what did you think was interesting?
Yeah, just to follow up on what Nick's saying, yeah, there's actually a pretty substantial working group of team to address the CI/CD system. Doug and myself are part of that. I'm currently moving our data center. So
I'm sorry, I'm having a hard time hearing. Is anybody else? Can anybody else hear Hong Tao?
I was not saying.
Yeah, it was kind of noisy.
Sure.
Sorry,
Yeah.
Hong Tao.
Yeah,
one
for
time.
me, yeah, I went there. So I see a lot of interesting going on. So especially like people start pushing forward the performance for GPU platforms on AMD on NVIDIA GPU, right? Like by extending DSLs and working on more advanced optimizations. So I think that's a good move. So Triton is really a nice DSL, but there's a performance gap between this one and other DSLs are kind of a hard blocker for some of the customers. I think moving towards that is a really good move. And also I like to see more people start using Triton, and like especially from LinkedIn, they're building more libraries on top of Triton. And also there are some posters for IBM. They were rolling out some Triton libraries. I think that's really nice and yeah, like cool. And yeah, that's my personal take.
Okay. Thanks, Hong Tao. Jamie.
Hi. Yeah, I was there at the conference. I think one thing that is interesting for me is to see kind of the divergence of people are trying different level of abstraction. And I'm curious to see which one of them will survive eventually. And the other thing is that I see there seem to be some attempt to do similar things, like in the Triton distributed presentation. They seem to have a different way of doing communication compared to symmetric memory from Meta. So yeah, I was wondering how those will maybe eventually evolve into the same standard, or will it keep diverging?
Good question. Kind of curious, what kind of kernels do you work on, or what have you? How are you using Triton, or are you using Triton?
Yeah, so me and my team, we worked on VRM GPU kernels. Specifically, this team worked on Mamba 2 kernels in Triton.
Mamba 2 in Triton. Okay.
Yeah, Mamba 2. Yep.
Okay, that sounds great. Continue to do good work on that. Okay. Next person is like Jie. Jie.
Yeah. Sorry. What's the?
Oh, the question was like the Triton Conference. Were you able to attend? Were there things that you liked that you didn't like? Things you'd like to see more of? Are there any special talks you'd like to call out?
Oh yes. I was impressed by the. I think the NVIDIA talk on the. I think they bring up the Blackwell extension on AREF, like kind of the new abstraction, and also there's a ByteDance's talk on their work as well. So I think it's good for different efforts to get to present, and yeah, I don't know, maybe we could have some like maybe panel discussion or whatever, maybe in the next one. But yeah, I don't have a better suggestion, but I think it's pretty good.
Panel discussion. Okay. Do you have ideas for like topics for your panel discussion? Yeah, like things that you'd like to see the panel discuss?
Maybe some like common like topics or concerns, or like the maybe directions to discuss, like because I think it's good opportunity for cross company level, like maybe collaboration or brainstorming of some like yeah.
Okay. And so I'm asking this for everybody else. What kind of kernels are you interested in, or things that you've been working on in Triton?
So is that also a question to me,
Or
or
a question for you also? Just just to just to wrap it up.
Oh yeah. For Triton, like I've been optimizing the Blackwell attention for Triton, and yeah, we're trying to enable the automatic warp serialization for yeah, if user just write like warp stack equals true, like we'll enable the compiler to handle all the partitions and scheduling stuff.
Okay, that's very interesting. Okay, JK. Keshav.
Hi everyone. I am new to this community, so just getting started. It's my first time. I was going through the conference talks, and they were quite insightful in how best to use Triton.
Okay. All right. Did you attend, or were you? Did you watch these remotely, or?
I watched them online. I was not there at the conference.
Okay. Online. By the way, what kind of kernels are you interested, Keshav, or like are you interested in writing optimizations? Kind of curious.
Yep. So on my side, I am quite interested in I would say like non-transformer models, and for those there's not a lot of good kernels being built. Everybody's focused on attention, which I think makes sense. So I just started to onboard myself on Triton. That's what brought me into the fold. Yeah, that's all from my side. Thank you.
Oh, excellent, excellent. Thank you, Keshav, and like looking forward to like any new kernels that you end up writing to, because we'll probably end up like using them someplace.
Yeah.
All right, Key. I'm gonna say Key. K-U-Y. Key.
Oh, that's me. I'm Kai. Bill, we've met a couple times, but okay. So for those who don't know me, I lead the XLA team for GPU at Google, and so we are an unusual user of Triton. Though I didn't attend the event on the 21st because I had to host a big event here for JAX and TPUs and stuff over here at Google. It was busy that day, but I would have loved to have come.
Okay.
And a few members of my team who were traveling from Germany did go. They're not here in the meeting today, and I have yet to compare notes with them. So I'm taking notes myself today so I can put those together later. But it sounds like there were some great talks. We are an unusual user in to answer your question preemptively, Bill, because we generate our own kernels through tileIR. And so we are interested in all kinds of things that we do with it. And we're particularly interested in the future as it applies to NVIDIA's roadmap and AMD's roadmap and so on. And what I'm thinking, and I wonder if there was a talk from the conference on the 21st, I'd love to see the recording if so, but I'm wondering if the language is evolving with all these extensions that have been mentioned, extensions and other applications, to track the future direction of GPU chips from the two major vendors as they evolve towards larger, matrix processing architectures rather than large SIMT type of designs as they've had in the past. So I'm really personally interested in, is Triton going to evolve as a language to follow these things? Maybe NVIDIA's talk has some clues in there, and maybe AMD has one too, to see sort of where the language is going. But that's my interest.
Okay. Not necessarily sure that I remember if there is one that was actually charting the future of like where we're going to be growing as a language. Other folks, if anybody else has like, if you remember seeing something, please bring it up, and so that we can like keep pointing to the right place. I'm also kind of curious to Kia, in terms of like what kind of kernels are your folks interested in also in terms of like the XLA part? Like, are there things that like you would like see more performance in? Like, just kind of curious.
So as I said before, we code gen everything dynamically, but we have a couple different families of templates that we construct kernels from for Triton. And obviously we have all these different attention paradigms, right? Including masking and all kinds of different scaling topologies and whatever. That's a big one for us. And part of the reason is that Google's TPU, for which there is no Triton support, and though we've looked at it a few times, it's not really something that we'll probably do because we think we have a better solution there. The TPU has lots of interesting quantization schemes that are unique to its architecture. And so what I do in my team is we often have to find ways of mapping one to the other, right? Because as Gemini is developed primarily for TPUs, my team's job is to make sure it works really well on GPUs. And as a result, we're often finding novel uses of, you know, the int4D type, for example, in certain kinds of scaling schemes that are proprietary. And as a result, members of my team are pushing the limits of Triton, which is partly why I'm interested in what can we do there and what does the roadmap look like for these new architectures. So yes, we have attention paradigms. Obviously, same sort of thing for normalization diamonds is our internal language for them, softmax type, RMS norm type structures. That's really interesting to us. And being general, right? XLA runs on a lot of different things, including we're the key technology that powers Waymos. They have a completely different set of workloads that are a combination of attention and convolutions and whatever, right? So we still care about convolutions, not as popular in the industry anymore, but my team cares about them. And there are a couple other customers like this. So while XLA does not currently do convolution cogen during with Triton, I'd love to take a look at it. That would be a super interesting use case that I'd care about.
No, that's very interesting. Convolutions under with Triton. No good. All right, so it looks like we've gone to the halfway mark. I want to say thanks very much, Key, and everybody else who like responded back regarding the conference. I'm going to give all this feedback back to Ofer. I think he's going to be really happy to hear about it. We're not going to pivot.
Yes, Bill, I attended virtually, so one thing was very, it worked pretty well. Attending virtually, the talks were there wasn't major recaps, a little bit at the beginning, but after that it was good. I didn't watch all the talks. For me, one of the most important or interesting to me talk was Ilium, the talk by Jason. Because it's becoming a lot more clear that Triton is actually not a performance portable language. It is only functionally portable, and here a little bit controversial. I work for Intel, and we have AMD. We used to have an Intel backend in Triton, but OpenAI really doesn't care at all other than NVIDIA GPUs and perhaps AMD GPU. So the Microsoft organizer posted the question after the guy from AMD was, presenting the MC. How do you get your backend in trees? So I like to see more backend in trees accepted by the OpenAI community. So that it becomes a real open source community and not just something that OpenAI has complete control. And they block the door for other vendors that may not have the most performant GPU in the market at the moment.
No, that's a very good point also, and that's something that I think a lot of teams also struggle with. And I think even like I think even like Simon and Brian, who are working with kernelized AI, they're also they have that same type of issue to figure out how they're be able to get their back into.
It kind of like given the PyTorch has embraced Triton, and PyTorch need to support different type of vendor and GPU, it would also make sense that Triton embrace the community and accept contribution from wherever they are.
I'm on board with you on there. And I see Luca has an hand raised.
Yeah, I want to just like add to that. I definitely think there's a lot of interest in, you know, the community to make this more of a community. And I actually want to bring up like in VLLM, we have this plugin system. So there's backends that we don't support in Tree, but they, you know, they can kind of like write their own plugin and plug into the kind of native VLM code base.
Okay.
And like the VLM itself is still very open source. So a lot of people who work on plugins, like people from Ascend, like Huawei, and I'm not remembering the other ones, but I know there's a couple. Like they will also work in the upstream. So I think like it doesn't need to mean that like if Triton becomes more open, that like all these backends have to go in. It could also be just like, no, there's like a, you know, people who want pluggability for other backends can work on this pluggability in the upstream and then still have their own plugin. Because right now, as far as I understand, it's actually pretty difficult, right? Like there has to be a fork, or yeah, just like difficult to maintain. So it could be more maintainable without being in the fork. Because I do understand like at some point you can't have every single backend in. I mean, right now there's only two,
Yeah, I
right?
agree.
So that's not
The
that many.
plugin idea is excellent, and you may also have a vendor that they don't want to expose their hardware because somehow, you know, it's only internal. But having a easy way to push a plugin.
So the plugin PR is up. It should be merged hopefully by the end of this week. If you have like mature use cases, reach out to me. We're in the process of gathering, right? Because we don't you know, we have the kind of buy-in to set up a plugin repository and fill them in with things, but we don't want it to be like just like a dumping ground of unsupported things. And so if you have something that's mature and you're going to sign up to maintain it and have tests, you know, let us know and we'll work.
Okay, thanks. We'll take a look at the plugin infrastructure. We'll circle back to you.
I
think there's a chat. Yeah, Puyan put it in the chat.
Yeah, I put up 3 of the PRs that we so far have been looking at. One of them, I think 8401 is the one we're trying to land right now. That's the meat of the pass plugins. We've already landed one that actually will alter the compiler.py pipeline setup, but obviously it can't load any native code from outside of Triton. It can only reorder or modify the existing passes inside of Triton. And then we're messing around a little bit with dialects as well. But right now we're really trying to just get the pass plugins upstreamed.
So if you want, I think you can reach out either to Corbin or to Puyan based upon like I think their addresses are inside the pull request, so you can reach out to them there.
Yes.
Okay, and same for you, Luca, too. So we're gonna pivot now to the next question or the next topic. The next topic is suggested by. Okay, I'm not gonna take full credit for this, so I'm gonna say Whitney. Thank you very much for suggesting this. It's a great topic. Between Gluon, TLX, cuteDSL, cutile, tileIR, and you name it, there are like I think 5 or 7 more dialects that are coming out for doing things similar to like what Triton does. How do you decide upon like which one do I pick, which one do I use to write my next kernel and my next model? And this is an open question out to the community about like folks who've actually tried using either Gluon or TLX or any of these other dialects. You know, what's your experience been, and like would you suggest people try using it? Does it make sense to use it, or would you have gone some other way had you had the opportunity? And I know there's some other people who are just waiting to like to talk about this topic. And I will start with Hong Tao. Okay, I'm bad. I will go with Hong Tao because I know Hong Tao has done some work with TLX, and he would like to say like where is it good, where is it bad, like how would you quantify what are good use cases for it?
Yeah, I guess that's very open question, and I do not have a good answer for that. But I will start sharing my experience and a lot of customers in Meta how they opt in new DSL. I think they typically start with Triton and proving its numerics and getting it work correctly. And then when it comes to production, they want something, or even during research phase, they want something more performant, so that because they got limited number of GPUs to operate on. So, but at that point, they have many choices, right? They can switch to Colors, cuteDSL, a lot of other DSLs. And what they typically want to do here is they want to stay with Triton, and they want to reuse their work, all the mathematics they have done there in their kernel. So they want to reuse that, and they are looking for an incremental way to do that. And so it made tags. But some of customers did switch back to Colors and cuteDSL. They start copying the standard kernel and tweaking it and make it work. It sometimes just works. And there's also a trend to switch to those DSLs, because pursuing performance, it never stops for some of the teams. So I guess it's a range of customers depending on their need. So I guess I don't have a concrete answer like which one I would suggest them to do. It all depends on they have dedicated timeline, they have their schedule, and how everything is makes them easier. So it's something so we are running RTX internally, and there are some customers that switch back to cuteDSL, and that's it all depends on their experience.
Okay. I'm kind of curious. Would you compare the maturity or the feature completeness? What would you say about TLX versus some of these other solutions?
It's just I think it's at a startup phase, so it's definitely not comparable to other commercial tools. So we are not supporting IP for a while. There's a lot of pitfalls. It depends on their user requirements. So it's still evolving. Yeah.
Oh, that sounds good. So other folks, anybody else tried some of the other solutions? Not just Hongtao, but looking around. Anybody tried Gluon or cuteDSL? Or do we have any Cutlass programmers? People who are diehard and say, I'm just going to go Cutlass or just do cuDNN. Otherwise, I will start calling out folks. What has your experience been in terms of trying some of these other alternative platforms? Hey Minjung, have you tried any of these platforms? Kind of like Minjung, because he's just the next one down on my list. Otherwise, I'm going to go down the next list. I see Preethi. Preethi.
I'm sorry, I missed your question.
Oh, sorry, Minjung. Is that Minjung or is that Preethi?
Yeah, this is Minjung. Yeah.
Oh, Minjung. Okay, so my question is, there's a lot of talk about all the different DSLs you might be able to use: Gluon, TLX, Cutlass, cutile, and all these other ones. Have you tried any of these other ones other than Triton? And what's your experience been?
Oh no, actually, I only Triton, but I have the similar concern. This time one of the biggest goal of the Triton is that making the hardware heterogeneity and sharing the same code over the machines. But it turned out right now due to the Blackwell, so we have now the big divergence, right? So the Gluon, TLX. So there was also my friends. They are not Triton experts. They are using the PyTorch, but they showed also big concern. What's the future of the Triton, given that it's the portability issues? So I love the Triton, and but the tile-based programming is it's a big. The goal, that is a good thing, but so we don't know what's the ultimate winner of the programming model kind of the war. But given right now the performance is so critical, so we can trade off the portability, but we really need to back to the portability in the long run. That is my impression, general Triton.
Okay, no, that makes a lot of sense. Getting back to a place where we actually have true heterogeneity or true portability across different platforms, making that pace.
Yeah, in that the Helium is kind of a very good approach. So Helium still try to keep the original goal of the hardware heterogeneity. So that is a kind of extension of the Triton. But yeah, but I don't know the tiling, other bunch of the other approaches. So actually, we don't know how we can merge or so, yeah, that is an open question.
Okay. Merge. All right. Excellent. Looking down the list, Sarah, I don't know if you want to like respond again. Also, you're coming down there. I saw Prithvi. I would say Prithvi or Puyan or Sarah.
Thanks. I haven't had a chance to try some of the other DSLs, but I'm looking forward to checking some of them out.
Okay. Yeah, because I'm thinking the one thing that would be kind of interesting, I don't know if we have a lot of them, would be good tutorials or I guess good YouTube videos actually showing how to actually implement some of them. Documentation, I think, is getting there. It's some of them can be kind of difficult to actually chart. Trying them out.
Yeah, I mean, I'm in the same boat. I haven't had the chance to really mess around with them, but I agree. I think having some tutorials would make it a lot easier to like get a hang of using them.
Okay. Using them, and I'm thinking that one thing that we, as part of doing the Triton bench work is some of these I think are also in Triton bench. Is she over here? Or maybe Hongtao, do you know that? If Triton bench actually has some of the Gluon, TLX, cutile, some actual demo code or some of the some actual kernels that people can see being profiled and actually see what they do, and they can actually go back and take a look at the implementations.
Yeah, we do benchmark those kernels. We benchmark flash attention from cuteDSL, from Calas, from FA4, cuteDSL, and Gluon, and TRX, and the Triton tutorial. We do provide a way to get a NCO profile automatically. So, but it's up to customers how to compare them, how to investigate them. So, yeah, it's a really good platform.
Okay, but I was just saying, but they have the sources available because the sources are available in Cutlass. And do you remember if they're annotated or not? Whether they actually have annotations in the kernels to actually explain like what's going on, or?
Oh, there isn't. So our open source Triton bench doesn't have, I think, Cutlass code. You need to hook it up. So, but it's easy to connect there.
Okay, that might be something we might want to add at some point later, so that people can actually get that all in one place.
I think that's like a very good point of having source code to how to easily implement in different DSL, but at the same time, I still think it's unclear to user of which one they should pick. They can try all of them. Now there's a better code, but still, which one should they pick? And before the conference, I didn't actually look at TLX, but after the conference, I get much better idea of it. I think please correct me if I'm like saying something wrong, Hongtao. From what you say in the Q&A, you're saying that this extension is more like a temporary thing and you hope to see it gone. While Gluon actually, it sounds like the motivation is very similar, but they don't make it sound like they want it to be short term. They want it to be forever. They think it's really, really difficult, if not impossible, to do it in Triton. So will you say that's to differentiate the two languages here?
I agree with them. So we're actually doing both in Meta. So we have effort parallel going on called AutoWS. So, but our work specialization is not only thing affecting performance. So we'll see where we can arrive. But I agree with them temporarily right now, at least a couple of years. Like DSL is not going away. Like fully compiled optimization wouldn't do everything. But it depends on users, like to what level of performance you want to achieve. You want 100% of the hardware limit, or you want 90%, like so, and also how much effort you can make on your side. So we are providing a range of choices there, and on the top is the DSL. So TRX Gluon, I think we are trying hard to make Triton as a whole better, and it will be and make sure the backend compiler generates a really optimal code compared to other compilers. So there is a way to get to ultimate performance with Triton. But if you don't want the effort, we also provide some automatic approach to get you there. It's not guaranteed. So people can write, arbitrarily intelligent kernels, like compiler would be messed up with them, but it takes time. So yeah, so
that's one of the difference, right? TLX runs the TTGIR pipeline, while Gluon actually try to do minimize optimization. The user will decide the layout, decide everything. So that's one of the different I learned in the conference as well.
Yeah. So it's more flexible. Gluon is more flexible.
Okay. I see we have a hand now. Luca?
Yeah, I guess my takeaway about Gluon was more that like it's not short term, but it's more of just like exposing the lower level like dialect and a way to help compiler writers, not necessarily to be used as an end user DSL. And also like it seems like NVIDIA has had, I mean, it's proprietary, but if they could figure it out, hopefully the open source community can also figure it out, maybe a little later. Like they've had good success, like doing more specialization automatically. So I guess my takeaway is actually a little different, but yeah, did I understand that wrong when I was at the conference?
From one of the previous Gluon presentation in this meetup, when they first present Gluon, they mentioned that actually Gluon is used in OpenAI production. So that gave me a feeling that they is going to use it, keep it for long term.
Right, but I thought that was the short-term part. Like Gluon is the long-term part, but it being used directly is the short-term part. At least en masse, right? I guess maybe there will always be some cases, but
yeah, guys, it's at the end of the day, it all depends on how hardware is designed. So if the machine can be made powerful to do more automatic scheduling, the hardware units then the software on the software level, the pressure is going to be lower, right? So at the end of the day, like moving on maybe years after years, just like how you can code on the CPU, you wouldn't pick up any. There's no fundamental difference between different languages, but for now it's not. Like the NVIDIA hardware right now is super configurable, and you need to get, I think, programming working really subtly well there. So, and their hardware cannot schedule those things very efficiently. So it's all depends on user. But I hope that's gonna be changed. Like if they start minimizing, building more lens channels between different function units and having hardware smartly schedule them. Like although the GPU actually CPU is more smart, more powerful in that part, but GPU has many cores, so each core has a generally weaker functionality compared to CPU. But this could be changed, right? So yeah, but I will see. I will keep an eye on that. So I guess that's a very challenging issue.
Another interesting point,
Go ahead.
not related to TLX or Gluon, on the other side actually, is at the last section of the Gluon presentation, he mentioned that, okay, Triton is not that because it's used for Torch compile, and it doesn't make sense to use Gluon or I guess TLX for Torch compile. So do you see that for Torch compile, it will continue to do Triton, or it may be switched to Helium? Because Helium is also higher level.
I don't really know, but I think targeting Triton is the primary roadmap here for PyTorch. So that enables a lot of other optimizations on high level, like graph fusion, kernel fusion stuff. So switching to targeting another language will be adding actual complexity, like how do you fuse Triton kernel into Helium or something. I guess that can be figured out, but right now, in short term, like Triton is still the primary target of inductor.
Excellent. Looking around the room, and also once again, asking the question: so far we've had a lot of talk about Triton and some talk about Gluon. Have other folks had experience working with like cutile or tileIR or any of the other IRs, and like share some of their experience with those? And looking around, seeing whether anybody would like to respond. Kind of curious. Okay, I'm bad, so I take full responsibility for this. Corbin, have you played around with any of these other IRs or any of these other languages?
Yeah, I mean the biggest thing that is that I think is not hasn't been totally figured out is like if you're going from Triton to like cutile, like they both have their own set of like layouts, and that's like a big set of like mental gymnastics to try to like work between like a cutlass layout and a Triton layout, and so that's potentially an interesting or a difficulty of like working between the two of them at the same time is hard. I think there was interesting talk by some of the NVIDIA folks about the implementation of how they did the cutlass DSL at the compiler level. I think that'll be interesting to see when it's kind of more mature and able to be kind of benchmarked.
Okay. Kind of curious, at AMD, yeah, which you have some familiarity with, do they have their own DSLs that they were thinking about, using, or is that mostly like other folks doing things? And this also goes to Simon too, or Brian.
Is Jason still on? Jason runs the AMD team.
Yeah, I'm still here. We don't have anything announced as a DSL. We do like the variety of Triton and then Gluon, right? So if you take a step back and you ask yourself like, well, why have other ones? Like what if we have Triton? Obviously, it's a good idea because everybody's like, oh, like I have sparking a bunch of development of like giving people power in Python to write kernels is a great thing, right? Like, and so maybe there's some criticisms and people come up with their own stuff, and you can't control shared memory directly from the Triton layer, like that's kind of one, right? But the closer you get to the hardware, then you're kind of like locked into that architecture as well. That's the push and pull here, right? And so if you're thinking about developing a new one, what's the main benefits? You've got to probably have to say, I want flexibility enough, but I also want like better performance than what Triton can give me today, and the pair of Triton and Gluon, you can go down a level, lock yourself to hardware a little bit more, but gain those extra performance, or you can kind of stay at this little more floaty level of Triton. But beyond that, like, do we need another? And do we need another one? Do we think we have another spot to kind of fill there? Is kind of the question. And then, are you targeting people to write this directly, or are you targeting things like XLA or Inductor to be able to program it too? Is an important thing to think about, I think, right? So, so that's just some thoughts. Nothing really announcing here from AMD and a DSL on our side, but from my view and our view, I think Triton and Gluon are cover vast majority of what we need at the moment. So, but yeah, just some thoughts there.
Okay, no, that's great. Thanks, Jason.
Sure.
And I see Luke has a hand raised. Oh, sorry. Go ahead.
Go ahead, Luke. He raised his. Go ahead.
I was gonna say, I'm curious, Jason, if like. So NVIDIA, like with their cutile, right, they also announced tileIR, and they made it, like it seems like they want some people to generate tileIR as well from Triton potentially, instead of generating, go through the full LLVM stack. And what I think is very interesting is like that allows for like different hardware architectures to use the same tileIR and like specialize at a later stage. So it's kind of like PTX, where it can be like compiled into something portable and then distributed in that format, and then the driver compiles the final stage from like a tile-based representation. Is that something that like AMD is interested in supporting? Because that if like NVIDIA creates this new like point of kind of lowering, like I'm curious if AMD could just plug into the same tileIR point.
I've not looked at it at that level, so I don't know if I can intelligently comment, but if it's abstracted to a point, then probably yes, right? Like the architectures here are fairly similar until you get down to the ISAs specifically, right? But yeah, I mean, and that's kind of an interesting point too. If we're talking about the layers below the DSLs, right? Like the lowering paths all the way down, because we don't have a PTX layer. We do rely more on LLVM to do that, and for good and bad, right? And if there's a standardization at like a lower level IR, that is interesting, I think, right? Especially as long as that's kind of open and community focused, is an important aspect to that from our point of view. So yeah, it's and if that's kind of a community focused kind of thing, we'd be like interested in the conversation for sure.
Cool. Keith?
Right. In the interest of time, I'll be brief. Any other hands raised? I'll just give you the Google XLA and JAX sort of perspective here, which is that we welcome our users to use a variety of different DSLs and to explore on their own what's useful. And so we know that our first party, like Google internal users, as well as our major third party customers of JAX on GPUs, they use a mixture that suits their particular needs. So we have some users who are making foreign function calls to cutless kernels. We also do that a little bit internally. We just added cuteDSL support through XLA for GPU, so that it's too early to say anything yet, but that will be coming soon. And then, of course, we have our own DSL. The JAX DSL is Palace, and Palace has some really amazing lowerings down to TPU on the one side and GPU through the Mosaic GPU architecture on the GPU side, where we are routinely seeing higher performance than equivalent Triton kernels. We just have different ways of making those abstractions possible. So you can have something that's high level and portable between chips, and then as you descend into deeper levels of abstraction in Palace and Mosaic GPU, you can sort of tickle those particular warp specialization schedules and whatever to get the most from the hardware. So that's sort of how Google has approached that one, but we're really encouraging our users to mix and match whatever makes sense for them.
In Palace, we lower that to Triton on our platform too. So that is kind of an interesting point, Kai, where, decoupling maybe the DSL user layer with, the lowering path underneath it, right? Giving a little bit of flexibility.
Exactly right.
Yeah, and just to add all of this, like we work with lots of different hardware vendors. Everybody had to build their own IR and their own DSL and whatever to get going, right? And it's sort of human nature to be like, I'm just going to grow this up and everybody's going to use it. But in reality, that hasn't really worked out. So I think this whole idea of interoperability and figuring out passes that are common, like keep this together as much as you can. That's something we're really trying to do. Is just keep the links and don't diverge too soon in the stack, because you just get into so many problems and then there's nobody that knows how to write these kernels. So
okay, thanks, Brian. So we have one last question. I only have 1 minute left, and Whitney, I'll let you ask that one, but I think it's related to flex attention.
Yes. So last meetup we talked about wanting to see flex attention backward pass to use tensor descriptor, and then so there are a couple issues open regarding that, and now there is a draft PR to change it for XPU, but I don't know if Meta or some other folks have spent any time to. What's the progress there? What's the status there?
Whitney, I can talk to this. So I just saw the PR yesterday. I think it's still in a draft. It came from someone from Intel, I believe.
Yep.
And yeah, I mean, we're very excited to get a contribution there. I was gonna, it was on my list of things to do if no one else got to it before me. But it's great to see that, people are contributing there. I'm gonna go through it myself, in more detail, add some comments. And yeah, I have myself and Driss from the PyTorch side who are looking at that PR, and yeah, we'll evaluate the performance and
actually one more related question for the team here. Sorry for taking the time. Tensor descriptor is something really critical for Intel, and we can hear from the NVIDIA presentation is also critical for Blackwell. So do we have plan to use it more often? Is it something welcome from the community if we change tutorials to use tensor descriptor and so on?
I think it would be accepted, or at least not accepted. I think you should actually propose and make a few changes and see how it goes out. I think people will take it.
Okay.
Yeah,
Yeah.
I would encourage it as well. Just
Yeah.
it's an optimization technique. Everyone should use it.
All right, folks, I want to say
anyone
thank you very much.
Oh,
Go
sorry.
ahead. Whitney. Go ahead, Whitney.
Did anyone actually try comparing the performance between tensor descriptor and regular pointer on a non-TMA hardware and see any performance difference?
I did not do it for non-TMA hardware, but for TMA hardware, we definitely get like, I mean, I can give you a example off the top of my head. Flex attention for document mask almost gives like a 30% higher performance than 30 to 50%. So it's like significantly better. For certain other ones where we don't really need that much, it's like sliding window, it's like lower. But yeah, it's a good performance boost, I would say.
Just adding to the tensor descriptor thing. Tensor descriptor have more information than tensor pointer. So there is already a path to lower tensor descriptor to tensor pointers in the Triton pipeline of passes. And there is no reason why tensor descriptor should not have the same performance of tensor pointers on any kind of architecture. I think we have done some experiments, and that is actually not true for NVIDIA GPUs, what I just said, but that's only because there is some, if you lower tensor descriptor to tensor pointer, the indexes for the offset are 64-bit, while for tensor pointers, they're 32-bit. So it may just be a question of fixing that pass upstream, and then you should be able to use tensor descriptor more pervasively on every architecture, even if it's not a Blackwell GPU, even if it's some other NVIDIA GPU. So that may be something that we want to upstream to facilitate that kind of work in PyTorch.
Okay. Is that good for everybody? Because I want to say we ran over by 3 minutes. I want to say thanks everybody for participating. Really appreciate everybody turning out and participating as part of the community. And thanks all. And I want to say thank you very much, Whitney, for actually helping run the whole shebang. Talk to you all later in about 2 more months.
Thanks, Bill.
Thanks, Bill. Bye.